Hello and welcome back. We'll finish up this section on quadratic equations by looking at some equations that don't necessarily look quadratic, but can be made to do so. So for instance, here we've got x is equal to 1 plus 6 over x. This is, to start with, not even a polynomial. A polynomial can only have terms that are, say, x to a power, x to a positive power times a number. So we can have x squareds, x cubes, and so on and so forth. But this is a 1 over x. So like this 6 over x term here, this doesn't belong in a polynomial. So right away, this isn't a polynomial, but we can make it look like one. My first instinct here is to go, I don't necessarily like fractions. Let's multiply everything by x and get rid of that denominator. So if I write this equation down again, what I can do is I can take both sides and multiply them by x. And what we'll see is that the fraction goes away. So we've got an x times x on that side. I'll need to distribute the x. So I've got a 1 times an x, which is x, and a 6 over x times x. So the x's will cancel on those to get 6. And now I'll move everything to one side. It's normally a little bit easier to look at quadratic equations where it's clear that we have ax squared plus bx plus c is equal to 0. And then from here, again, in sort of order of ease, I think the first instinct would be to see if I can factor this, and then maybe using the quadratic equation would be nice, or even completing the square if the question asks us. But first, factoring is generally going to be the easiest way if it factors nicely, and that's a big if. So let's try to factor this. So I'll have an x and an x to make the x squared. And then I need to find two numbers that multiply together to get -6, and that add together to get -1. So to get 6, I can multiply, for instance, 3 times 2. But I need it to be -6. So one of these is going to be negative, either -3 and 2 or -2 and 3. And they have to add together to get -1. So I definitely want the 3 to be negative and the 2 to be positive. Again, when we multiply these together, we get -6. When we add these together, -3 and 2 will give us -1. And again, this is still equal to 0. So I know that one of these two expressions has to be 0. Something times something is equal to 0. The only way that happens is if one of those is 0. If the one on the left is 0, then x is equal to 3. Or if the one on the right is 0, then we have x is equal to -2. So we have these two solutions. And here I want to give a very big warning. We need to check our answers. And why am I saying that we need to check our answers now, as opposed to before when we weren't checking our answers for the just for regular polynomials? And this is because for polynomials, the solutions will always exist. If we find solutions to a polynomial, they are solutions to that polynomial. This wasn't a polynomial to begin with. And in fact, in our first line, what we do is we multiply both sides by x to try to find this. And we're noticing that we are dividing by x here. So if x were 0, I can't plug that into our original equation, because if I plug a 0 in, 6 divided by 0 is not defined. So there are numbers that don't work here. And if there's one number that doesn't work, there's a potential that there's more numbers that don't work. So what we need to do is just quickly plug these in and check to see that everything works. So let's plug 3 into here. So plugging 3 into the left-hand side clearly gives 3. But if I take 1 plus 6/3, 6 over 3 is 2, plus 1, that does equal 3. Okay, good, so that one works. Let's try -2. if I take 1 plus 6 over negative 2, 6 divided by 2 is 3, so this is negative 3. 1 plus negative 3 is in fact negative 2. So both of these work. We got lucky, and both of our answers work. So let's do one final equation here. And again, when we look at this, we see a square root. We think right away this is not going to be a polynomial because we've got a square root sign in here. So how can we deal with a square root sign? Well, if we don't like square roots, let's just square everything and make our lives easier. So we'll have x is going to be equal to the square root of 2 minus x over 3. Let's square both sides. So if I square the left-hand side, I've got x squared. If I square the right-hand side, I'll get 2 minus x over 3. And now, again, maybe I don't like these fractions, so I can multiply everything by 3. If I multiply the left-hand side by 3, I get this. Multiply the right-hand side, I get this. And let's move everything over to this side, plus x and minus 2, 0. We have ourselves a quadratic polynomial, so we can just factor this, or at least try to factor this, and if we can't, we can use the quadratic formula. So let's see if we can't factor this. We have to have our two terms multiply together to get 3x squared. So I'm going to put a 3x and an x, so that when I multiply these together, I'll get the 3x squared. And then I need to multiply two things to get negative 2. Well, there's only two ways to multiply numbers to get to get negative 2. It's either going to be a negative 1 and a 2, or a 2 and a negative 1. So we'll try this for now. Negative 1 and 2, so when I multiply these together, I'll get the negative 2. But for the middle term, if I do the inner terms, I'll get negative 1 and x, so that's negative x. And 3x and 2, so that's going to multiply to get 6x. So 6x and minus 1x, that doesn't add up. Okay, so that's not quite right. And in fact, if we think about it, if the 2 is on this side, I'm going to get either a 2x, or a 2 times 3x, which is 6x, or negative 2 times 3x, negative 6x. That seems pretty big. So let's put it on the other side. And again, what I can do is, we'll see, I'm going to take the 2 times the x and the 3x times the 1, and I want to add it up to be positive x. So I'm going to put, what do I want? A negative there and a positive there. Why? 1 times 3x, negative 2 times x, and that adds up to the x that we see in the middle. So everything works out. Again, all this is just equal to 0. I found this by factoring, just trial and error, and then a little bit of intuition. Again, the more you do, the easier it becomes. And again, we want either of these to be equal to 0. So 3x minus 2 is equal to 0, or x plus 1 is equal to 0. And then solving these, moving 2 to the other side divided by 3, or x is equal to negative 1. Let's just make that look a bit nicer. So again, what we started with was not a polynomial, so we do need to check if these make sense. So let's check this one on the left-hand side first. So we had the square root of 2 minus x, which in this case is 2/3, divided by 3. Yes. So let's simplify this. 2 is the same thing as 6/3, and 6/3 minus 2/3 is 4/3. If we divide that by 3, this is going to be 4/9, and the square root of 4 is 2, the square root of 9 is 3, so this is going to be 2/3. And that works. Okay, so this is one of our solutions. Let's try negative 1 now. So we have 2 minus a negative 1 divided by 3. 2 minus a negative 1, well, that's going to be 3 divided by 3. And 3 over 3 is just 1. And the square root of 1 is 1. But it's meant to equal x. 1 is not the same as negative 1. So here's the first situation where negative 1 is in fact not a solution. And we can see this immediately because x being equal to the square root of a number, the square root of a number is always positive. So negative 1 cannot be equal to the square root of a number. So it's impossible for this to be a solution. So it's a good thing that we checked our two solutions that we found. X is equal to 2/3. We can plug that in and it is a solution. X is equal to negative 1 is not. So we do need to check. And it is important when this is not a polynomial. If it is a polynomial, you can still check. It's good to check your work. But at the same time, the solutions that you find are guaranteed to be solutions. If it's not a polynomial, that guarantee no longer exists.